The moment you see a deep-sea creature, your brain doesn't just think weird, it feels wrong. These animals didn't evolve to disturb us. The extreme environment they live in forces evolution to produce shapes and bodies that look completely alien to human instincts. And you're right, it isn't. These animals didn't evolve to disturb you. The conditions they live in are so extreme that the physical solutions evolution landed on are genuinely alien to every instinct a human carries. The environment punishes normal biology so severely that what survives looks like nothing your brain has any reference for. The deeper you go, the more pressure builds. At 3,300 feet below the surface, the pressure already hits 100 times what you feel on land. At the deepest point in the Mariana Trench, nearly 36,000 feet down, it tops 1,000 times atmospheric pressure. That force destroys hollow spaces. It collapses lungs, crushes air bladders, and implodes anything holding a pocket of gas. What you get instead is a body that looks incomplete, gelatinous, almost melted, because physics literally demanded it. The anglerfish is probably the first deep-sea creature most people picture. The female looks like something assembled from spare parts. Her body is round and slack, her jaw permanently open, and her teeth are so disproportionately large she physically can't fully close her mouth. That jaw looks diseased. It isn't. It's always open by design. In a place where food can disappear for days or weeks, you can't afford hesitation. The open mouth is a standing trap that costs zero energy to maintain. And in the deep sea, energy is the most precious currency alive. What sits above that jaw is called the esca, a spine evolved off her dorsal fin, tipped with living bacteria that produce bioluminescent light. It pulses. It dangles directly in front of her mouth. Other fish at that depth have spent their whole lives in complete darkness, and anything that glows means food. They swim toward it. She eats when she can, as much as she can. The next meal could be very far away. Here's where the anglerfish stops being visually disturbing and starts being biologically disturbing. The male is born tiny, barely the size of a jelly bean, with one job: find a female. In total darkness, with empty ocean in every direction, that's nearly impossible. He navigates by scent, tracking chemical signals through absolute black. When he finds a female, he doesn't court her. He bites into her and fuses. His circulatory system connects to hers. His organs begin shutting down one by one. His eyes go. His digestive system goes. His brain shrinks. What remains, permanently attached to her skin and fed by her blood, is a small sac of reproductive tissue that exists for exactly one purpose. A single female can carry up to 8 males at once. That's not a metaphor. It's documented, peer-reviewed vertebrate biology. The technical term is sexual parasitism, and it's the most extreme form of sexual dimorphism known in any vertebrate species. It evolved because in permanent, featureless darkness, with vast distances between individuals, finding a mate once and keeping them forever is mathematically better than searching again. The system looks horrifying through a human lens. Through evolution's lens, it's a solved problem. Then there's the issue of eyes. Vision is so useful that evolution invents it independently about 40 separate times across animal lineages. But it needs light, and below 3,300 feet, there is genuinely zero sunlight. Not dim. Zero. So the animals down there either abandoned eyes entirely or rebuilt them from scratch on different principles. Both happened, often in the same animal, and the results look like they were designed by someone who'd only ever heard eyes described secondhand. The barrel-eye fish has a completely transparent head. Not translucent, fully see-through like glass, with 2 bright green cylindrical eyes mounted inside it that rotate upward to detect prey silhouettes against the faint glow from above. For decades, scientists examining specimens had no idea the eyes could rotate, because the fish gets crushed coming to the surface and the mechanism breaks. It took MBARI researchers filming a live barrel eye in its actual environment to confirm the rotation existed at all. They had been studying a feature they had never once seen function correctly. Nearly 76% of deep-sea animals produce bioluminescence, their own light, through chemical reactions inside their bodies. Down there, it's not a quirk, it's the majority. Light in the absolute dark isn't decoration, it's communication, camouflage, and weaponry packed into one system. Some line their undersides with tiny light organs and precisely match the faint glow filtering from above, erasing their own shadow. A technique called counter-illumination that makes them invisible from below. The first time you are introduced to these animals on film, as they are pitch black and have no reference points in their environment, the impact of the image is very different to anything you see in nature. The human brains were developed in such a way that when there is an abrupt flashing light in the dark, it is linked to certain danger, lightning, fire, predator eyes. The dragonfish is a different category of wrong. Unlike almost any other deep-sea animal, it produces red bioluminescence. That matters because red light doesn't penetrate seawater past about 165 feet, meaning at any real depth. No red light exists in the environment at all. Most deep-sea animals lost the ability to detect red wavelengths generations ago because there was never any red to see. The dragonfish turned that blind spot into a private flashlight. It can illuminate prey without triggering any visual alarm in that prey, because the target literally cannot perceive the wavelength. A 2019 study from Boston College found that some dragonfish species evolved specialized photoreceptors to detect their own red light, making them both the only producer and one of the only detectors of that wavelength in the entire deep sea. There's another category of disturbing deep-sea body design, the ones that look like they shouldn't be able to hold themselves together. The fangtooth fish, Anoplogaster cornuta, holds the record for largest teeth relative to body size of any fish in the ocean. It's about 6 inches long. Its lower canines are so disproportionate that it evolved dedicated skull pouches to slide them into when the mouth closes. Otherwise, they'd puncture its own brain. A 6-inch fish with structural engineering problems that serious. Then there are the ultra-black deep-sea fish, documented in a 2020 Current Biology paper. Researchers identified 16 species reflecting less than 0.05% of light that hits them, the second darkest biological material ever recorded. A densely packed layer of melanosomes in the skin is arranged specifically to trap and scatter incoming light rather than reflect it. When a submarine spotlight hits one of these fish directly, it barely appears at all. Your eye keeps expecting detail and gets nothing back. Deep-sea gigantism compounds everything. Animals that are small in shallow water have relatives at depth that can be 3, 5, even 10 times larger. Giant isopods, essentially enormous roly-poly bugs, grow to about 20 inches. Their land relatives don't reach an inch. They have 14 legs, compound eyes on the sides of their heads, and segmented armor plating that looks identical to trilobite fossils from 300 million years ago. Because the body plan that works down there doesn't need to change. They survive over 4 years without food, running on stored fat, slowly moving across the floor of the Gulf of Mexico, while the surface world cycles through seasons they'll never experience. The leading explanation for deep-sea gigantism is metabolic rate. Cold temperatures slow metabolism, allowing cells to keep dividing past the stopping point that governs surface animals. Reduced oxygen pressure and lower food competition may also reduce the cellular stress that normally limits size. Whatever the mechanism, the result is the same. The familiar creatures you know from shallow water keep showing up at depth at sizes that cross a different threshold of discomfort than simple unfamiliarity does. The vampire squid's name is misleading in almost every direction. Vampiroteuthis infernalis, literally vampire squid from hell, is neither a squid nor an octopus. It's its own lineage, a living fossil that split off from both groups hundreds of millions of years ago and hasn't meaningfully changed since. It reaches about a foot long, ranges from deep red to absolute black, and has blue eyes proportionally larger than almost any animal its size. When threatened, it pulls its webbed arms over itself like a cape, presenting spiny outer projections toward whatever's approaching. That looks aggressive. It's actually a last resort defense from an animal that doesn't fight. What surprises most people, the vampire squid doesn't hunt at all. It lives in the oxygen minimum zone, roughly 2,000 to 3,000 feet down, where oxygen drops so low most animals can't survive. The vampire squid floats there and uses 2 long sticky filaments to collect marine snow, dead particles, microscopic waste, organic bits falling from above. It has a blood pigment with higher oxygen affinity than nearly any other cephalopod, allowing it to function where most things can't. The disturbing name comes from how it looks, not what it does. The giant phantom jelly, Stygiomedusa gigantea, looks like something from a production that didn't ask too many questions. Its bell reaches up to 3 feet across. Its 4 ribbon-like arms extend up to 30 feet. It has no tentacles, no stinging cells, no active hunting mechanism. Anything that drifts under its bell gets wrapped in those arms and gradually consumed. Mbari had recorded it only 9 times in 30 years of deep-sea research before their 2021 sighting, meaning that despite being enormous, it is genuinely one of the least observed animals on Earth. We don't know how it reproduces, how long it lives, or how it navigates. We barely know it exists. Part of what makes it so unsettling is the complete absence of recognizable features. The phantom jelly has none of that. It's a large, slow-moving mass with trailing arms, glowing faintly under a submarine's lights, and there's nothing for your brain to lock onto. No anchor point, no reference, just something enormous in the dark. The snailfish is now the record of the deepest fish filmed. In September 2022, scientists at the University of Western Australia recorded video at 27,349 feet in the Izu Ogasawara Trench off of Japan, establishing a record that was only a few months earlier in the same trench. They are not at all what you would think the deepest vertebrate on the Earth should look like. They are little, pale, almost transparent, and they have no scales visible. and their body totally disintegrates when it is brought to the surface. Every cell is tuned for roughly 800 atmospheres of pressure, and at 1 atmosphere those cells simply fall apart. Specimens physically collected in 2023 arrived at the surface as unidentifiable tissue. Over 95% of the ocean is still unexplored. Every dive brings back something that doesn't fit any category we had before. Something that glows when nothing should glow, survives where nothing should survive, or holds together at pressures that should make a body impossible. What reads as disturbing is simply what life looks like when it solves problems we've never had to solve.